typically like when body is subjected to any disturbance, and it will tend to vibrate, okay, in a particular motion, that is called as vibration. Okay. So motion can be either periodic or random. Okay. Some of the examples I'll show further, but motion of a simple pendulum and motion of a blade or motion of a tuning fork. So these are some of the things which are common in so some of the other examples are strings of violin, mobile phones. Give me one. Hello?
దాని స్టార్టింగ్ సెంటెన్స్ చాలా అందంగా వచ్చిన మార్చాలి, అది మారలేదు ఇంకా. నేను అందుకే స్వామి వివేకానంద దీంతో మొదలు పెట్టాను. అంటే సైన్స్ ఇవన్నీ కూడా హ్యుమానిటీ కోసం పనిచేయాలి అని తీసుకుని అక్కడి నుంచి ఈ గ్లోబల్ సిటీ అవ్వాలంటే ఇలా డిఫైన్ చేశారు. నెట్లో తీసాను కొటేషన్, హ్యుమానిటీ అని చెప్పి స్వామి వివేకానంద కొట్టాను. చాలా రిలవెంట్గా ఇంకా ముందు చూస్తున్నాం ఒకసారి. అంటే అబ్రాడ్ అనేది కూడా చాలా వాల్యూ.
Water plates and bridges. So these are some of the simple examples. One is simple pendulum and spring mass system and tuning fork. So vibration happens when body has an inertial and restoring force.
Has a long
so if you see in a spring and mass, so definitely there is a restoring force acting on it, as well as inertial force. Similarly, case with the simple pendulum as well as tuning fork. So what exactly is natural frequency? It's like when body is initially disturbed and left free, then the frequency with it oscillates is known as natural frequency. So one of the important questions comes, how many natural frequencies does body have? That is one question. Second question is, what is the need for finding the natural frequency of a body in vibration? Okay. So these two questions are very important as per stressor perspective. Okay. So how many natural frequencies does a body have? So the body might have like n number of natural frequencies. Like for example, if you see the cantilever beam, so it is having various frequencies. These are some of the frequencies we have listed out here. Okay. And what is the need for finding out natural frequency? So this is one of the another important question. So what could be the answer? The answer is like when we extract natural frequency, we need to check for the resonance. So what exactly is the resonance? So hope we have been studying about resonance maybe from 10th class onwards. Resonance is like frequency of a body coincides with the external forcing frequency or operating frequency. Then the phenomenon will call resonance. So what will happen like when natural frequency and external operating frequency matches, then there will be a resonance, and the damage will be huge. So the complete component may collapse. Okay. So this is so it is very important for us to analyze the component, structural component, find out the natural frequencies, and we need to see these natural frequencies have good margin from the external forcing frequency. So another condition for resonance is to occur is forcing frequency and natural frequency are to be in same phase. So this is also one more condition they should, and as frequencies matches, then resonance will occur. So these are the basics of vibrations and natural frequency and resonance. Let us look into basic equation. Okay. Let us take single degrees of freedom.
13 universities. We have 13 state universities, state funded universities. state fund
in any damper. So it is subjected to external force. So when you take a free body diagram, this is the external force acting on it, and there is a restraint on spring as well as damper. Okay, and there is a acceleration. So from the Newton's third law of motion, we can give F equals to ma. So that can be converted into this equation. So the net force will be Ft minus Ku minus Cu. Double dot is nothing but acceleration. So overall equation is given like this. Okay, mu double dot plus Cu dot plus Ku equals to F. This is the equation of motion, where U is the displacement, U dot is velocity, and U double dot is acceleration. So this is the equation of. So for free vibrations means there will be no external force acting on it, and also there will be no damping. Okay. So what will happen, like T will be 0, force will be 0, and damping parameter will be 0. So then mu double dot plus Ku. So let us assume this body will be having a motion in terms of U into sin omega t. Completely periodic motion. Let us assume it will have a omega is the frequency of oscillation, and U is the amplitude. This is the undamped free vibration. So when you substitute this equation here, this equation will become like this. Okay. Minus omega square into m plus k into u equals to 0. For non-trivial solutions, you must have this equation should be 0. Non-trivial is non-zero solution. So substitute the here 0 equals u is a trivial solution which we are not interested. So we are interested in non-trivial solution, and it gives us so which will lead as omega equals to root over k by m. The frequency is given by omega by 2 pi. So this is how like frequency is derived for single degree, and this is the undamped free vibration. Now the question comes, we are telling that what will have to introduce damping. So when you introduce damping, then the difference between the undamped and damped is like this. Okay. So it will gradually reduce. The amplitude is gradually reduced. So for damped natural frequency, these are the some equations given below. So this is damped frequency equals to omega into root over 1 So these are the basic some of the equations related to damped natural frequency. So for structural damping, typically this value lies between 0 to 0.15. So usually generally it will be 1 to 5%. This is 15%. Typically it will be into 5%. So approximately damped natural frequency equals to natural frequency. That's the reason we ignore damping in normal model analysis. When you try to do any model analysis, we generally ignore the damping frequency, factor. The reason is the damping ratio is very less. That is 1 to 5%. When you try to substitute here, then damping frequency will be equals to natural frequency. Undamped frequency. Now let us see some equation of motion related to multiple degrees of freedom. So equation of motion is given like this: mu double dot cu dot plus ku equals to external force. So where u is the nodal displacement vector, M is a mass matrix because we are having multiple components here, multiple bodies are here, so we need to work on matrix. C is a damping matrix, K is a stiffness matrix, F is a forcing vector. Done. Here also we will ignore damping factor because we are not seeing much impact. Impact of damping coefficient and actional force is 0. So the equation becomes mu double dot plus K equals to 0. So this is the equation of motion. So assume displacements vary harmonically with the time. That is, so this is the displacements varying with respect to time. Okay, U bar is a vector of nodal displacement amplitudes. It comprises of multiple location, multiple displacement values. It's other. So when then this is the velocity equation and this is the acceleration equation. So again, when you try to substitute all this into this equation, then equation becomes like this. The equation of motion becomes like this. So for non-trivial solution, generally we need to we are interested only non-trivial solution. That is, this should not be 0, and this factor should be 0. Okay. So if you do this, we will get a result. So when you try to make it 0, we will get nth order polynomial of omega square. Okay. So it will have multiple values coming here, not one value. Like single degrees of freedom, we got only one value. Here we will get nth order of polynomial of omega square. So for which we can find n solution, n number of solutions for omega. So the omega I is nothing but 1 to n or the natural frequency. So whatever values we get, n number of values, all are natural frequency. So first one, out of which first one, omega, and it is also called fundamental frequency. So whatever the frequency we achieve is called fundamental frequency, and it is the smallest frequency. So when you try to substitute omega 1, omega I here, omega I is one value, it gives one solution. So
the intention is to
so if we have n number of omega values, we'll get n number of solutions. So this one solution is for omega I. Similarly, we have n number of omega i's. So we'll get n number of solutions. So from this one, omega I are the omega this u bar I is the normal mode. What exactly the modes are, we will discuss later. Also called as natural modes or mode shapes.
Appropriate place.
So this factor will get frequency values, and from here when we try to substitute those things, we will get mode shapes. So now coming to model analysis. Okay. So what exactly is the model analysis? Basically, model analysis we do is to extract the natural frequencies of a particular component and the respective mode shapes. So each natural frequency will have one mode shape, okay, respective mode shapes. So basically, we'll do model analysis to determine natural frequency and mode shape. So if you see here, for particular given one solution, when you try to substitute omega 1 particular frequency, we will get normal modes. So each frequency will have unique modes. So for model analysis, damping is ignored. As we discussed, why we are ignoring damping. We are not seeing any importance to the damping. It is not causing significant impact on the overall natural frequency. That is the reason we are ignoring damping. And also we are not we are any loads are applied on the component also we are ignoring. Okay.
Best technology.
So that the mode shapes, what exactly mode shape is? The displacement phenomena. Now displacement in the component when it is vibrating is also called as mode shape. So when you try to vibrate a thin sheet, okay? So it will, when you try to put it like this, it will try to vibrate.
Problems. Arise in agriculture.
It will vibrate. Okay. This reflection is also displacement is also called as mode shape.
Through IoT, we are addressing the problems can be addressed at a two words. We address our level. We address through IoT. We address.
Magnitudes of displacements or stresses in the normal model analysis have no physical meaning. So when you do a model analysis, always you should look into the displacement behavior. The magnitudes doesn't make any sense, either in displacements or stresses. So those things are not to be considered for any stress analysis. So in model analysis, our area of interest should be how the mode shape is, what is the frequency value. Those two things only. We should not extract displacements and stresses from the model analysis. This is very important point. For normal model analysis, no support of the structure is necessary. Okay. So this is also very important thing. So in general, when we perform stress analysis, we generally suppose if I want to do any analysis on the component, we need to subtend at this location. Otherwise, singularity in the stiffness matrix will cause rigid body modes. So in model analysis, the constraint may not be required. Okay. But what will happen? It will give zero frequencies. So these zero frequencies will give rigid body motions of whole or part of the structure. Okay. So when you don't give any constraints in the model analysis, it will give rigid body modes or rigid body frequencies. Also, model analysis, apart from checking frequencies, this model analysis, some of the groups or companies are used to check finite element model quality. Basically, we can check it on the models.
We collaborated with.
So whatever last
so basically, like from model analysis, what we do is we extract frequency.
So you need any technical support, you need to call me at least before.
We extract frequency mode shape.
Like for uploading PPTs or anything.
So now it is very important. What are the dependencies of these two things on the overall component? There are two things. If you see here, like when you try to do any analysis, there will be geometry.
Related information in the aware.
There will be load.
There
will be body. So these are the three things generally model analysis depends upon. Okay. So if you see frequency is given right 2 pi. So
అంటే ఐడియాస్ ఆల్రెడీ చేసాము.
F is the proportion to
వర్క్షాప్స్ ఫస్ట్ వర్క్షాప్స్ హెల్డ్ and
So,
some 21 ideas were filtered.
K is the stiffness.
21 ideas
Right?
were filtered in a
So,
workshop.
a component
Okay, మరి అది రాద్దామా సార్? మీ ఆర్గనైజ్ చేయవచ్చు అని చెప్పి
అంటే
ఐడి రాసి
అదంతా రాస్తే స్పేస్ ఉండదు, అందుకని అరౌండ్ 21 ideas were filtered in a workshop organized.
ఓకే మరి ఐడియా
అవును, అది కదా నువ్వు రాసిన. నేను నీకు ఎందుకు రాయించాను ఇప్పుడు అర్థమైంది ఆ రోజు.
so, frequency is directly proportional to
Around 21
root over K.
ideas
So, what exactly, how we can get the stiffness?
filtered.
So, basically the stiffness factor, stiffness is depends upon geometry parameter.
In a recently organized workshop.
Type of configuration. Geometry is coming from geometry parameters, like if you take typical bar of cross section A, length L, times modulus is A is given by A is by geometry, another is length that is L. So K is directly proportional to geometry as well as length modulus. So frequency is directly depends upon geometry parameter and length modulus. So
in collaboration with government,
apart from frequencies
in collaboration with government
and the mode shapes as well are function of structure properties and boundary conditions. So what will happen if we change the structural properties? Okay, if we change any structural properties, like instead of if you see here cantilever beam, instead of E, if you try to double it, what will happen? So if you try to double it, so instead of E, we are making it as 2E, then the frequency definitely increases. But the mode shapes may not increase. Still the cantilever behaves, the typical mode shape is constant. It won't depends upon its modulus or material properties or geometry. So cantilever will have the mode shapes, or simply supported beam also have fixed mode shapes. So only when you change the properties or geometry details, only frequencies will change.
ideas are filtered.
So if boundary conditions are changes, then it will change natural frequencies. This is our cantilever. If I want to change this cantilever into simply supported beam, what will happen? Like complete geometry behavior will changes. Okay. This beam behavior itself changes. The primary reason is
In
there
collaboration with
is
industry and
it
government.
is instead of fixed support, it is simply supported, and mode shapes will be changed at the same time natural frequencies.
Students were filtered.
So natural frequencies basically depends upon geometry parameters, boundary conditions, but mode shapes primarily depends upon boundary conditions. So that's the reason we'll have different mode shapes for cantilever, different mode shapes for simply supported beam.
And collaboration with industry.
ప్రాసెస్ ఇప్పుడు మార్నింగ్ ఆఫ్టర్నూన్
మార్నింగ్ collaboration with industry. అయిపోయింది అంటే ఇండస్ట్రీ పార్ట్నర్స్ కూడా పట్టుకొచ్చేసాను ఇందులో. అది ఇండస్ట్రీ ఐడియా అనుకుంది. గవర్నమెంట్ తో కొలాబరేట్ చేసినప్పుడు అరౌండ్ 20 స్టూడెంట్స్ తో ప్రాజెక్ట్.
This is the one router. If you see here,
నెక్స్ట్ కావాల్సింది ఏంటంటే
so if you see here, this is a typical router. This is one mode. This is also called as umbrella mode, and here this is called drive. So
నెక్స్ట్
this is bending something like
కెపాసిటీ బిల్డింగ్ అనేది
మార్నింగ్ వస్తాను
now to make the story. Paragraph.
so. First mode is umbrella mode. Okay, this is uniform throughout with this. This mode is uniform throughout 360
Capacity
degrees.
building
If you see this mode,
among students
the blue line indicates
is a vital component.
0th line.
వీళ్ళకి ముందు వెబ్సైట్
This one is moving. Okay.
అందులో ఏంటంటే
So similarly, this one is
Moocsa.
this mode is nothing four nodes,
Support email.
4 quadrants. So this is 0 1, this is 0 1, this one is moving.
నెక్స్ట్ అందులోనే మనకి ఫేస్బుక్
So similarly, next we have another mode here.
నెక్స్ట్ ఎప్పటికప్పుడు నేను ఏం పెట్టినా మన వెబ్సైట్లో పెట్టినట్లనే దాంట్లో నోటీసులు పెట్టాను. నెక్స్ట్ ఈమెయిల్ ఏంటంటే ఇప్పుడు ఎవరైతే ఫ్యాకల్టీ చెప్తున్నారో
So here also we have
వాళ్ళ స్టడీ మెటీరియల్ అందులోనే పెట్టినాను.
301.
అది డైరెక్ట్ యాక్సెస్
So and it is all these quadrants are moving.
అందులోనే అసైన్మెంట్లు ఇంకా అందులోనే టెస్ట్ కనెక్ట్
So this is somewhat related to our symmetry of the model. Okay. So this behavior generally we need to understand which mode is critical for our cyclic symmetric analysis. When you try to do any cyclic symmetric analysis of a component, any rotor, okay, it is very important to understand which type of mode is significant, okay, and it should be avoided.
అంటే అన్ని
So all these things it all depends upon type of rotor you are analyzing, type of
బాగోలేదు ఇది అది అని నాటకాలు దొరుకుతాయి.
adjoining components it is so this is pretty advanced topic, but as you guys are doing working these initial stages, you try to understand
వీడియోస్ ఇస్తున్నాడు ఇక్కడ ఏంటంటే
model analysis
Total
is used to extract
అన్ని lectures
frequency of the
చెప్పు.
component and respect to mode shapes.
వీడియో లెక్చర్స్
So these frequencies are used to check the operating frequency of a particular component,
టీచర్ నువ్వు రా
and
శనివారం క్లాస్ లో వచ్చి నేను అసైన్మెంట్ ఇస్తాను. ఈ అసైన్మెంట్ నేను ఇక్కడ పక్కన
it should be away from
మీరు ఎవరు ఏవి వచ్చే ఏవి రాలేదు స్టూడెంట్ ఇంటరాక్షన్ పెట్టాను. వీడు ఆడుకు దొబ్బడానికి వీలు. అప్పుడు చచ్చినట్టు వీడియో పబ్లిష్ చేస్తున్నాడు లేదు తెలుస్తుంది. వీడియోలో వచ్చి వాడు ఇంటరాక్ట్ అవ్వాలి.
అది మనం ఎక్సెల్ వెళ్ళాలి. కారణం ఏంటంటే ఇప్పుడు అంతా మూసంలోనే మనం ఖర్చులు వేస్తూ
అవునవును.
ఆల్మోస్ట్ 80% సక్సెస్ తీసుకొచ్చాం సార్. ఇప్పుడు ఇవన్నీ ఇంట్రడ్యూస్ చేసి నేను క్వాలిటీ
stabilize
కూడా
చేశాను.
చేసి మనం పెంచిన తర్వాత ఇది
అప్పుడు
చేయగలం. నెక్స్ట్
అవునండి అదే నేను
so let us take this is our
దట్ ఈస్ ది గోల్ టు అచీవ్. ఫ్లిప్ క్లాస్ లో ఉన్నది అల్టిమేట్ కాన్సెప్ట్ వెళ్ళాల్సింది. టువర్డ్స్ దట్ చిన్న చిన్న మూమెంట్స్.
ఇంకోటి ఏంటంటే ఎన్ఐసి వాళ్ళు ఉద్యోగ సర్వర్ లింక్ ఇస్తారని నాకు తెలిసింది. ఎన్ఐసి వాళ్ళు మెయిన్స్ పెడుతున్నాం. ఒకవేళ అదైతే కనుక మనం సర్వర్ ఆఫ్ చేయకుండా
so this rotor let us say
వీడియోస్
operates
వెరీ గుడ్ అదో ట్రై
speed of
చేస్తే మనకి ఎన్ఐసి సయ్యద్ ఇక్కడ హెల్ప్ చేస్తాడు. ఎన్ఐసిలో ఏమన్నా పెద్దవాళ్ళని పట్టుకుందాం ఏముంది మేడంతో మాట్లాడించి ఎన్ఐసి దీనికి ఆవిడ సపోర్ట్ ఇస్తారు. మేడం సపోర్ట్ ఆవిడ అసలు పని చెయ్యాలి ఇదని కానీ ఎంతెంత పెద్దవాళ్ళని కలిపేస్తారు.
తెలుసండి ఆ సర్వర్లు ఆఫ్ చేస్తే పనిచేస్తాయి.
తెలుసండి మెయింటెనెన్స్ లేదు. అవును అది కాదు నాకు ఇంకో ఐడియా వచ్చింది. వదిలేసి నేను ఆ పాయింట్ అనబోతున్నాను మీతో. ఎలా వదిలేసి బదులు ఏఎంసీ లేదు అప్ చేసిన
so let us see how the resonance will be calculated. So when you try so now let us convert this into
రెగ్యులర్ వచ్చాడు తప్పేసి చేసి చెడిపోయింది. నాకు అది మొదలా ఉంది కానీ మీరు దానికి వర్కింగ్ కాబట్టి మంచిగా పెట్టి అప్పుడు కుర్రాడు అనుకున్నాను కదా అలాంటివంటి పెట్టాక ఇంకో దీనికోసం ఒక నెట్వర్క్ పర్సన్ పెట్టి అప్పుడు వాడితో ఆఫ్ చేయించినట్టయితే మీకు నడుస్తుంది. మీకు అర్థం కదా వీళ్ళందరూ దేవదేవ్ శానిటైజ్ వీళ్ళందరూ జాన్ జిగిరి వస్తారు. మొన్నడే వెళ్ళేది
ప్రపోజల్ ఏ విధమైన ఇది లేదండి. కాకపోతే అక్కడ
అదంటే అది 25-30 లక్షలు
okay, this is the frequency. Now this is the operating frequency. Now we need to do model analysis of this component and we need to identify the frequency. So when we try to run this frequency, so model analysis of this component, so suppose if I get first frequency, suppose if I get
అది రాసి
165
సిఎస్సి ఏరియాలో
and so if you see 155 and 160, they are very close. Generally, we'll keep around 10 to 20% away from the operating frequency. So 10%, 20%. Let us put 20% here. So 20% is 30. So it should be 190 hertz, but we are at 155. So there may be chance of getting resonance here. So to avoid the resonance, our component should be having 190. So this component should be having 190 hertz. So how to make 190 hertz? How to get the component with 190 hertz? This means how to increase the natural frequency of the component. So we have that equation Fp equals to 1 by 1 by root over K by L. So here only way we can increase the frequency changing the thickness.
అండ్ ఇండియాలో
We can play either change the material
ల్యాండ్ లైన్ నుంచి మాట్లాడతాను
or change the geometry.
ఆయన నాకు
So these two things we have to do.
మెయిల్ అయితే నేను పెడతాను
This is how we will do. First we will do the
రాజన్న
model
గారే వాటర్
analysis,
ఆయన కాల్ చేసి మాట
and check with the operating
అంటే
system,
mobile
how much frequency it is operating. So if it is very good, then
అలా అయితే అంకుశం
then we need to go for revision.
చేసి
Change the
ఒక
complete
రెవెన్యూ
design
క్లర్క్
or revision which is having higher ranks model.
చాలా జేసీ కూడా రాజన్ గారితో ఫోన్ లో మాట్లాడు నా జేసీ ఫోన్ లో మాట్లాడతాను
ఇప్పుడు ఒకసారి జస్ట్ ఇలా అనుకుంటున్నాం మీకు ఏమో చెప్తుంటారు.
So let us take one more example here. This simple cantilever.
అంటే ఒకసారి ఫ్లో పోకుండా
So what we have done is we fixed here
మళ్ళీ
constant in all degrees of freedom.
దీనిలో షేప్
These are the
లాస్ట్
properties and these are the material properties. Here we need to give compulsory density for modular
ఒక
analysis.
ఇది సబ్మిట్ చేయి
Because
లండన్లో
the main reason why we need to give density is our
చెప్తున్నారు కదా. అదే
our basic
creativity ఉన్నవాళ్ళు
frequency equation depends upon thickness.
ఇది చేసిన వాళ్ళేమో అడ్మినిస్ట్రేటర్ అయ్యారు. అది ఏం చదివితే నిశాని గారు 9th క్లాస్ వాళ్ళు
మన
వాళ్ళు ఇల్లు దొక్కుతుంది వీళ్ళు మనం దొక్కుతున్నారు.
ఎవరు వీసీ గారు
Mass of the component. So that so finite element analysis we calculate mass,
ఇక్కడ కూడా
volume,
అడ్మినిస్ట్రేటర్స్ కూడా
and then
వాళ్ళని
it has
చెప్పకుండా
to back calculate the mass. That can be calculated through density.
అడ్మినిస్ట్రేటర్ మనం దొరుకుతున్నాడు అది
So here we need to give Young's modulus, Poisson's ratio and density, and we need to run the model analysis. So if we see here our first frequency is 36, that is natural fundamental frequency is 36, then 178, 227, 401 like that. So let us see the mode shapes. This is our first mode shape. This is the first mode shape. Okay. This is perfect deflection of cantilever, vertical direction, and this is also cantilever deflection, but in lateral direction. This is vertical direction, and this is lateral direction into the plane.
అయిపోయిందండి
This is third mode,
చూద్దామని వచ్చాను.
and this is the fourth mode. This is fifth mode here.
మంచిది
This is another mode, cantilever. This is also one more mode. This is another twist mode here, and this one is a mode. So like that, like each frequency will have unique mode shapes. Okay. Now let us do analysis without constraint. So I did not give any constraints here, and when I run the model, so this model generates 6 degrees of freedom.
అది
అది లేకపోతే
Rigidity. These first 6 degrees of freedom, first 6 sets gives the rigid body.
లేకపోతే ఏంటంటే ఫోన్ చేయి.
Means with zero frequency. Some frequencies 230, 630.
అది చూస్తున్నాను ఆటోమేటిక్ అయిపోతుంది చూస్తున్నాను.
So if you see here,
మీరు కలుద్దామని చెప్పి
and it is simple rigid body mode, completely moving. Component is completely moving, and here also this is also rigid body mode, and this is also component is moving. See here, this component is completely moving at this point. From center is the reference point. Similarly, here also component is completely moving. Here also. So mode 5, mode 6 also zero frequency. It's almost zero. These values are almost zero. So first 6 modes we have rigid body modes.
First semester. First year onwards. First year until 30th semester. One
So if you see here mode 7
first year
and
onwards,
mode
you
8,
should follow the
they have regular modes. So mode 7 is 230 frequency, mode 8 is 630 frequency.
onwards in the engineering curve. First year. In the engineering curve. Correct. Yeah. చాలా కాంపాక్ట్ ఫాలోయింగ్ సబ్జెక్ట్స్ అని చెప్పి అవన్నీ ఇక్కడ కాపీ పేస్ట్ విత్ అంటే మధ్యలో వస్తాయి.
So if you see here, this is a typical cantilever. Whatever we solved is a similar thing. So these are the typical modes. So this is vertical, the vertical deflection mode. Here also vertical deflection mode. There is a deflection happening at the end as well as at the mid location. These are two different modes, and here also there are three points deflection is happening here, and here.
Engineering curriculum. In computer engineering curriculum.
So once we complete this class, if you go back and study your basics of vibrations, you can understand about the importance of vibrations. So vibrations are very useful, especially when when there is a load is subjected in a dynamic environment. The thing is like when we use this equation of motion. So when you try to use the equation of motion, the forcing frequency, if the frequency of the applied load, either if it is depends upon time or depends upon the operating frequency, it will have significant impact on the overall geometry. So it is so to study this effect of this sign load variation depends upon temperature. The force function either depends upon time or frequency. So these are the dynamic load. So whenever there is a dynamic load happening on the component, so model analysis is also very useful. So one model analysis is an input for some of the analysis. One is random vibration. Second one is seismic vibration.
Sorry, EVMS
Seismic is nothing but our regular electric wave whenever any
but జరిగిన క్లాస్ బాగా జరిగింది.
vibration analysis, harmonic analysis.
అంటే ఇక్కడ మన వాళ్ళ మేరకు నేను కొంత కవర్ చేశాను. ఈఆర్ మోడలింగ్ కవర్ చేశాను విడిగా.
These are some other analysis which require model analysis.
మనం ముందుగానే ప్లాన్ చేసేసి
Apart from this, the model overall, whenever you design a model, the model analysis is required to check the resonance factor against the operating frequency.
ఇప్పుడు ఈసారి అన్నా చేస్తే బాగుంటుంది. ముందు పెట్టాను అది ఇంపాక్ట్ చాలా ఉంటుంది. అంటే అది ఏమన్నా అంటే జనాలందరికీ ఏదో లేదు పట్టించుకున్నట్టుగా ఉన్నారు. ఊరికే యూనివర్సిటీ గవర్నమెంట్ అంది కాబట్టి చేస్తాం కదా.
So that's all from my side. If you have any questions, I can address. So tomorrow I'll be completing the chapter 5. The chapter 5 remaining topics is static analysis, and another one is buckling analysis. I'll cover both the things tomorrow, and then we'll have one more session on understanding the case studies. So if you have any questions, please let. Any questions? Jntuk Kakinada, Vijayanagar. and Vishnu Institute of Technology.
ఇది కెపాసిటీ బిల్డింగ్ చేశాను. కెపాసిటీ బిల్డింగ్ చేశాను. విత్ దిస్ బ్యాక్గ్రౌండ్ స్టూడెంట్స్ కెన్ బి ప్రొడక్టివ్ ఇన్ డేటా అనలిటిక్స్, ఐఓటీ ఇన్ అదర్ ఏరియాస్ అని చెప్పి సెంటర్స్ వచ్చేసాయి. అంటే అక్కడ ఐఓటీ కన్నా ఇక్కడ ఇవే చెప్తారు ఏంటని స్టూడెంట్స్ కెన్ స్పెషలైజ్ in IoT, data analytics, data analytics, and other related advanced technologies.
Any questions? Okay, if you don't have questions, then we'll meet tomorrow at 10:50 and we'll